So I'm doing problem number 8, and right off the bat, just from the picture, it gives us the initial angle after being fired from the cannon, with also a initial velocity, which the magnitude is 50, and the angle is 37. So if we just go straight to making our triangle, we do sine to find the vertical because it's opposite over hypotenuse, and then cosine because it's adjacent over hypotenuse to find horizontal. And after we do these two equations, we come out with our answer to A, which is the initial horizontal velocity is 40 and the initial vertical velocity is 30. And so next we go to B, which is how many seconds does the cannonball stay in the air? And we're going to put our delta, vertical displacement as 0 because it's starting on the ground, and then we're figuring out how long it stays into the air until it hits the ground. And so then we're looking for our delta t. So if we just enter in all the numbers we have, which is the initial velocity and the acceleration, which it also gives us, and since it's gravity, it's pulling down, it's negative. And this gives us a quadratic. And then once I entered it into my calculator, we got delta time is 6. So that gives us our answer to B. Next is how far from the cannon will the ball land? That is asking us to find the delta x, which is the horizontal displacement. And so again, if we just enter everything we know from this equation, the only difference between these two is it's delta y and delta x. Since acceleration is 0, because it's what we do, it gives us just initial velocity times delta time, which is 40 times 6, which comes out to 240. And so that's our answer to C. And then D is how high above the field is the cannonball at its highest point? So we're going to divide the time by 2 because we're just assuming that after 3 seconds it reaches its peak and then starts to drop, and then 3 seconds later it hits. And so we're looking for delta y again because it's high vertical displacement. And so we're going to give everything we know already, but in this case we're going to divide time by 2, as I said. So it's 30 times 3, which would give us 90, and then minus 15 because, again, the time is divided by 2. And that would total out to 60. So at its highest point, the cannonball is 75 above the ground. I think that is everything. Yeah. All right.